Okay, so we're on lesson 1.5. This is for Mrs. Cucci's College Now PreCalculus class. What we're going to be talking about today is linear equations, functions, zeros, and applications. Okay, so by the end of this lesson, you will be able to solve linear equations, solve applied problems using linear models, and find zeros of linear functions. Okay, so an equation is a statement that two expressions are equal. To solve an equation in one variable is to find all the values of that variable that make the equation true. Each of these values is the solution of the equation. The set of all solutions of an equation is called its solution set. A linear equation in one variable is an equation that can be expressed in the form mx plus b equals 0, where m and b are real numbers and m cannot equal 0. Okay, so when we have any real numbers a, b, and c, we've got a couple of principles that are always true. The first one is your addition principle, and that says if a equals b is true, then a plus c equals b plus c is also true. And that should make sense, because if a equals b, then essentially what you're saying is a plus c equals a plus c. Multiplication principle works the same way. If a equals b is true, then a times c equals b times c is also true. So those are just a few principles that we use. All right, so we're going to go ahead and solve this. Nothing new here. You guys have been doing this for a long time. Okay. So our first step is to isolate x. So we have to undo order of operations, right? So we're working SADMA. So we're going to undo subtraction by adding. So we're going to add over that 1. So 7/5 plus 1 is the same thing as plus 5/5. So we get 3/4 x equals 12/5. Okay. And now we have to get rid of that 3/4. Okay. So what we're going to do is we're going to multiply both sides by 4/3. And we do that because that simplifies to be 1. And we get 48/15. And that reduces to 16/5. Okay? And of course, you can check your answer to make sure that it is correct by using your store function. All right, next page. How could we solve this graphically? Find the solution using the page, the graph page on the next page. All right, so my equation is 3/4 x minus 1 equals 7/5. How can I solve this graphically? Now remember, an equation is two expressions that are set equal to one another. So what we could do to solve it graphically is graph each side of that equation. So we start with our left side, which was 3/4 x minus 1. And then we graph our right-hand side, which was 7/5. Okay. The solution to the equation is their intersection point. Okay? We know how to find the intersection point. Menu, geometry, points and lines, intersection point. You click on one, click on the other, and then your intersection point pops up. I'm just going to move it so it's easier to see. We have 3.2 and 1.4. So 3.2 is your value of x that is your solution. All right, so that's how we would do it graphically. All right, so let's go ahead and solve this one. Now, this one's a little bit longer. There's more steps that are involved, but it's not difficult. We always start by distributing, so we're going to do that first. 10 minus 6x equals 8, and now we're distributing through the negative 3, minus 3x minus 6. Next step, isolate the x. Get all the x's to one side, all your constants to the other. So I'm going to add over the 3x, which is going to give me minus 3x equals 8 minus 6, which is 2. We just combine like terms. Subtract the 10, and divide by a -3. So we get a solution of 8/3. Okay, let's try another one. Again, we're isolating the x. So we're going to start by getting all of the x's to one side. So we're going to start by adding over the 24x. And what winds up happening is we get 0. So this equation doesn't work. We have no solutions here. Okay, no solutions to this equation. These are, in fact, if you were to graph each side of your equation, these would be parallel lines. There's no intersection point. All right, again, we've got the same situation here. I've got -1/3 x, -1/3 x. If you have the same value on each side of the equal sign, they cancel each other out. All right, so again, no solution. All right, so you're always watching for that. If you don't have a variable to solve for, you can't solve. All right, so we have 5 steps for problem solving. Your first step is to familiarize yourself with the problem and situation. You want to make sure that you read it carefully. If the problem is presented in words, you really do. You have to read it more than once. Some or all of the following can be helpful. Make a picture. It's a really good idea to make a picture. Make a written list of the known facts and a list of what you want to find out. You can assign variables to represent your unknown quantities. You can organize your information in a chart or a table. You can find further information by looking up formulas or consulting a book. You can guess or estimate and check your guess or estimate. Translate the problem into mathematical language. Carry out some type of mathematical manipulation. Check your work. Does your answer make sense? Okay, so if you have a problem and the answer doesn't make sense in the context of the problem, we usually reject, so keep that in mind. And then state your answer using a complete sentence. And I want to make sure that you guys are doing that, because when you go to college, when you take physics, you're going to have to write your answer out in a sentence form. Okay. All right, so words and language. There are about 232,000 words in the Japanese language. This is about 19% more than the number of words in the Russian language. How many words are in the Russian language? Okay, so we're going to solve this out as a word problem. So, first thing we need to do is familiarize. We know what we're trying to find. We're trying to find how many words are in that Russian language. And we know that it's 19% more than the Japanese language. Okay, so what we're going to do is we're going to translate this into math. All right, 19%. Okay, so we have the Russian language, which we can say is X. And then we have to add to the Russian language 19% of the Japanese language. So 19% of the language X. Okay, so this is what we're kind of trying to figure out. So what we're going to do is we're going to say, and we know we can't write it as a percent like that, so 0.19x. Right? We know that this is going to equal 232,000. Okay? So, this is 1.19x. It's 232,000. And what we're going to do is we're going to solve for x, because x is our Russian language, right? Divide by 1.19, and we get x to be 195,000. Okay, so there's about 195,000 words in the Russian language. The other way we could have done this is we could have looked at 232,000 and figured out what 19% of that number was, and then added it to 232. I'm sorry, subtracted it. We have less words in the Russian language. Okay, so that's the other way you could have done it. You could have taken 232,000 and multiplied it by 0.19, and you would have gotten 44,080. So then you would have taken 232,000 and subtracted 44,080. Okay, and that doesn't come out right for some strange reason. All right, so we're going to move on from that one. We'll come back to that. All right, convenience stores in 2011. There were over 146,000 convenience stores in the U.S. The total number of convenience stores in Texas and California was 25,047. There were 3,885 more convenience stores in Texas than in California. Find the number of convenience stores in Texas and California. All right, so I'm going to bring up another page because this is a lot. Okay, so what we're going to do is we're going to do a couple of let statements. We're going to let X equal the number of stores, convenience stores in California. Okay. That means that X plus 3,885 is going to be the number of stores in Texas, okay, because we said it had 3,885 more. So when we translate this into words, we're going to say that the number of convenience stores in California, or X, plus the number of convenience stores in Texas, X plus 3,885, equals 25,047. Okay, so now we can go through and solve this out. 2x when we combine like terms, and then subtract. And then divide. Okay. So if X is 10,581, then X plus 3,885 is going to give us 14,466 stores. Okay. So in 2011, there were 14,466 stores in Texas and 10,581 stores in California. Some days Okay, so everybody already knows motion formula. Motion is distance equals rate times time. That's nothing new. You guys have done that a million times, so it's just on there for an FYI. Okay, so airplane speed. Delta Airlines fleet includes B737 and 800s, each with a cruising speed of 531 miles per hour. And Saab's 340Bs, I guess 340Bs, each with a cruising speed of 290 miles per hour. Suppose that a Saab 340B takes off and travels at a cruising speed. 1 hour later, a B737-800 takes off and follows the same route, traveling at its cruising speed. How long will it take the B737-800 to overtake the Saab 340B? All right, so back to that paper. So the first thing we need to do is think about what we have. We can make a drawing showing what we know and what we don't know. We can say that T is going to be time, which makes sense. Okay. and that should be in hours. And we know that since the Saab takes off 1 hour before the 737, it's going to travel for time plus 1 hour before being overtaken. All right, so they're going the same distance. If I draw a picture, right, same distance. We've got one plane, and I can't draw a plane. It's probably going to look more like a fish. And another plane, which is behind it. Here's your planes. They look like fish, don't they? Well, they're planes. Okay, so we want to figure out how long it's going to take for them to meet up. Okay, so we're using distance equals rate times time. Okay, you can make a table, which we haven't done, so let's practice that. We're going to say that this is my distance, and we know that the distance is the same for both of them. This can be my rate. Okay, and we know that the 737 is going at a rate of 531 miles per hour, and the 340B is going at a rate of 290. And then time, we're saying that my 737 starts at T, and an hour prior was my 340. Okay, so we've got two equations here. We have D equals 531T, and we have D equals 290 T plus 1. Okay. So we want to know when they're going to be equal to each other. We want to know when they're going to meet up, be at the same distance. Okay. So same distance, meaning these two are going to be equal. 531T equals 290 times T plus 1. Now we know how to solve this equation. We're going to distribute through that 290. Okay. We want to get all the T's to one side. So 241T equals 290. And then divide. So we get T to be approximately 1.2. And remember, that's in terms of hours. Okay, so it takes about 1.2 hours for the plane to catch up. Okay, so it looks like I have about 2 minutes left, but I don't want to get into simple interest today because I have a couple of ones that we're going to do with simple interest. So we're going to stop here today. So please make sure you come in with any questions, and we will go back over the problem with the language. I'm not sure why that didn't work out. Maybe I typed a number in wrong, and I'll double check that. All right, I'll see you guys tomorrow.